Hi, previously I have talked about how to construct a convolutional neural network, and I have used the network to train using the MNIST database, and then I used the model to recognize my own handwriting, and then I can get about 95% accuracy for the prediction. And today I'm going to talk about what exactly is the convolutional neural network um, is doing in terms of mathematical calculation. And I'm only going to talk about the convolutional layer and the max pooling layers, as in the Keras package, which is something like this you will see when you train a convolutional neural network. So first of all, let's create a input or an image as an input. So here I have a 5 by 5 matrix. So if you have watched my video for training the convolutional neural network, MNIST database, actually the order image is 28 by 28. So the input matrix is actually a 28 by 28 matrix. But to simplify for this video, I create a 5 by 5 matrix here. So that will serve as my input to the model. So I only have one image to train, and then I also have one filter. So as I put in one in for the filter, so I have one filter. So this filter is actually the parameter that you are going to train. But here I'm just going to use let's pretend we have a pre-trained filters here, and then I'm going to just to explain what the convolutional layer and the max pooling layer is doing in the convolutional neural network. So uh, actually, the convolutional layer is actually using the filter to scan through all the pixels of each image. So for example, I have a 3 by 3 filters or a kernels here, and I have a 5 by 5 matrix. So the convolutional neural network is actually using this filter to multiply by the first again by the same number of elements in the input. So here I have a 3 by 3. So the neural network is actually using this filters to multiply by the first three rows and the first three columns of the input, and then I also have the strikes equal to 1. So that means my second calculation is going to move to the right by one more element. So my second multiplication should be using the same filter to multiply by the first three rows, but columns 2 to 4. And my third calculation, moving to the right by one more element, should be using the same filter multiplied by the first three rows again, and then 3 to 5, column 3 to 5. And so after each multiplication, which is the inner product, so that means I'm using a 9 elements multiplied by 9 elements in this image, and then take the sum. So I'm just to elaborate more. So I'm going to just do one examples, just for a better understanding. So that means for the first multiplication, I'm going to use 1 multiplied by 3, and 1 multiplied by this 3, and then 2 multiplied by this 2, and then I'm going to use this 2 multiplied by this 1, and then use this 2 to multiply by this 0, and then use this 0 to multiply by this 1. And then I'm going to use this 0 to multiply by this 3, and then use this 1 to multiply by this 1, and then use this 0 to multiply by this 0. And then after the multiplication, I have 9 numbers, and then I take the sum of all 9 numbers. So that will be my first element for my first multiplication. and then strikes equal to 1, that means I move to the right, and then I use the same filter to multiply by the next 9 elements in this matrix, and then again using the same filter multiply by the next 9 elements. So eventually I should have a 3 by 3 matrix as an output, since I have 5 by 5 input image and then a 3 by 3 filters. So just to let you understand, I also write my own function to expand this, what exactly is this line doing in a convolutional neural network. Okay. So let's input the input image and then the kernel to the environment, and then this is the function that I write it from scratch. So this entire function, it is exactly can be done by one line from the Keras package. But the purpose of this video is just to elaborate what exactly is this line doing. So here I have this function, and then now let's take a look. So I'm calling this function and then taking in the input, which is the 5 by 5 matrix, and then the kernel, which is the 3 by 3 matrix, and strikes equal to 1. That means I'm moving one element moving one element to the right and to the bottom at a time. And then I will talk about this padding equal to 1 later. And actually, let's change this to 0. Okay, so here I have this 3 by 3 matrix as an output. So as you can verify from our image, you can have this 1 multiplied by 1, so 3 plus 3 plus 4, so that's 14, plus 2, that's 16, plus 0 plus 0 plus 0 plus 1. So that's 13. Sorry, I lost I lost myself here. So it's 6 plus 4, 10, and then 12, and then 13. Yeah. So you can validate that the 13 is actually come from using this kernel multiplied by this 9 element. And then you can pause the video to verify it again to using this 9 elements to multiply by this 9 elements and then take the sum. So eventually you should have a 6 by 6, 3 by 3 matrix as an output. Okay, and then we also have a max pooling layer. So this output is come from the first line here, using in the convolutional layer, and then we also have a max pooling layer. So the max pooling layer is very easy to understand. So here I have a the pooling size is equal to 2 by 2, and then actually the strides is still equal to 1. But I'm just ignore from the function. I don't need to type it out. So that means so the max pooling layer is actually and I also defined the matrix, the pooling size 2 by 2. So that means for each 2 by 2 space, I'm only extracting the maximum value over there. So in our case, here for our output 3 by 3 output, and then over the 2 by 2 space, for example, column 1 and 2, row 1 and 2, the maximum value is 13. So my first elements of the output from the max pooling layer should be 13. And I also have strides equal to 1. So again, moving to the right by one more elements. So I'm looking about this 4 elements here. So the maximum value of this 4 value again is actually 17. So my second element for the output from my max pooling layer should be 17, and then for the third elements should be 11, and then for the fourth elements should be 14. Okay, So now let's run the max pooling layer, and then we get this 4 by 4 matrix here, and then we can see and then we just verify the elements here. So that is exactly what the Keras package or the convolutional layer and the max pooling layer is doing uh, of a convolutional neural network. So it looks like it's very easy, but but think about that when you have 60,000 image, and then and then you might have 32 or more than 100 filters to train, and then each filter can be is a 3 by 3 or 5 by 5 matrix or even more. So think about the parameter that you are going to train in a convolutional neural network. It will be enormous. So that's why we have this pooling layers just, and then or if you have watched my video, we also have the dropout layer. So that means and as you can see from our examples, that we start from a 5 by 5 matrix, and then after the first convolutional layer we drop down to a 3 by 3 matrix, and then after max pooling layers we drop down to a 2 by 2 matrix. But still we have more than, of course, we are going to have more than one filters, and then we can have also different kernel sizes. So we have enormous amounts of parameter to train, and then but we are also keep reducing the number of input and output through the layers. So if you have watched my videos in R or Python, we are very likely, when we train a convolutional neural network, we are very likely to have more than one convolutional layer or more than one max pooling layers. We might have three of these two layers in a model, and then after that we also have the fully connected layer where we flatten uh, the output, and then to make it the regular neural network. So again, we have an enormous amount of convolutional of a parameter in a convolutional neural network, and so in order to make it more efficient, and also to make it faster, or to avoid overfitting, we will also try to reduce the size as we keep pushing the data or the numbers to our next layer. So so that's the concept of a convolutional neural network, and then the mathematical um, uh, algorithm of what exactly is this two layer doing. So right now I have shown you about one filter, and then 3 by 3 kernel size, and then strikes equal to 1, and then padding equal to valid. So valid, that means there's no padding. So the output is that from a 5 by 5 matrix we have a 3 by 3 output, and then after the max pooling we have a 2 by 2. So now let's take a look on when, so so actually what the code that we have run is actually only this part, where we have strikes equal to 1 and padding equal to 0. So now let's talk about when the strike is greater than 1. So that means after my first multiplication, I'm moving to the right by 2 elements here. So this 9 element is first, this 9 elements is multiplied by this 9 elements here, row 1 to row 3, column 1 to column 3. But when the stride is equal to 2, that means we move to the right by 2 more elements. So the second multiplication should be using the same kernel multiplied by only these 9 elements. So we skip one multiplication in the middle, as in the case when we have strides equal to 1. So in strides equal to 2, after this 9 element, we directly go to these 9 elements, 2, 1, 2, 1, 3, 2, 0, 2, 1. So we skip the 9 elements in the middle because we define that the stress is equal to 2. So we move 1 and 2. So our starting point is this element here. So because we define the stress equal to 2, our output should now be a 2 by 2 matrix after the convolutional layer. Okay, so now let's run the code again, and the I have so feel free to pause the video to if you want to understand the if you if you want to take a look at my codes. So here so of course when I have different stripes and padding, I should have a different section of the codes to take care of the moving part, the moving the filter to scan the image. So after our previous examples, now I'm going to use the stress equal to greater than 1, but the padding is still equal to 0. So here I'm going to define the stress equal to 2 and padding equal to 0. So as we have talked about before, that our output should be a 2 by 2 because now we are moving 2 more elements per per multiplication. Okay. Yep. So the output is now 2 by 2 elements. So the 13 is actually come from this 9 elements multiplied by the filter. And the 17 is come from this 9 element multiplied by the filter. And again, we move to the right by 2 elements. We also move down by 2 elements. So the 8 in the output is come from these 9 elements multiplied by these 9 elements, and the other 8 is come from these 9 elements multiplied by the kernel. So as a result, we should have a 2 by 2 output in this case. Then let's take a look at the max pooling. So our max pooling, the pool size is still 2 by 2, but our output is only 2 by 2. So again, the output from our max pooling layer should be 1 element, since we are trying to capture the maximum value from a 2 by 2 value, a matrix in a 2 by 2 size. So now let's take a look at the output. Let's run the function again. And as you can see that the maximum value of this 2 by 2 with 2 by 2 pool size is actually the 17. Okay. And now we have covered different different number of stripes, and now let's take a look on the padding. So padding is actually adding zeros at the border of our input image. So here I also have a third chunk for stripes equal to 1 and padding equal to 1. So previously, for both previous 2 examples, I have padding equal to 0. So that means I'm not doing any adjustment for my input image. But for my third examples here, I have padding equal to 1. So that means I'm adding one like a border outside this matrix. So my input is 5 by 5. When I have padding equal to 1, I will have a 7 by 7 matrix because I have a column 0 here, a row of zeros here, and then a column 0 again here, and then a row 0 here. So I'm adding like 2 more rows, 2 more columns on both sides, and then two more rows of zeros on the top and bottom. So eventually I will have a 7 by 7 matrix as my input. So that's the adjustment that is done by the padding. So let's take a look of the for this special case. So let me just define the parameters here, and then I will have input equal to, so my new input should be a 7 by 7, and then I'm just create a 0 matrix and then input the original matrix in the center, in the middle. So that is equivalent by adding a padding or a border outside my original matrix. and then so that my new output will be, since I have a 7 by 7 matrix and then my kernel size is still 3 by 3 and then stride size equal to 1, so my output should be 1, 2, 3, 4, and 5. So because I adding 0, my output size is also changing. So in the case when my padding is equal to 0, for a 5 by 5 matrix scanning by a 3 by 3 filters and then stride size equal to 1, I have a 3 by 3 matrix as an output from the convolutional layer. But when I have a padding equal to 1, that makes it a 7 by 7 matrix input matrix, and then the kernel size is 3 by 3. And with the stride size equal to 1, so that means I should have a 5 by 5 output from the convolutional layer. So if I have a padding equal to 1 and stride size equal to 2, that means I have a 1, 2, and 3. So again, I should have a 3 by 3 output. But in this video, I only talk about the cases for stride size equal to 1, padding equal to 0, stride size greater than 1, padding equal to 0, and then stride size equal to 1 and padding equal to 1. So you can also, so if you want to test that whether you fully understand the concept or not, you can also try to do stride size greater than 1 and padding is equal to 1, or padding stride size greater than 1, padding greater than 1, so that you can test your it is actually very easy to understand, but you can use this as a programming exercise to test your programming skills here. Okay. So again, so let me just run the output for the stride size equal to 1 and then padding equal to 1. So that is actually doing the multiplication within this chunk here. So again, my output should be a 5 by 5 matrix. So let's verify that. So as you can see that we have a 5 by 5 matrix. So by adding a zeros at the border, so that means when I'm on the side of this matrix or in the for the multiplication, I'm actually using the first column and the first row multiplied by all the zeros. So again, so of course, the corner or the border one are smaller because I have 0 multiplying by the kernel. And so now let's take a look on the max pooling layer for this 2 by 2 for this 5 by 5 output, and over the size 2 by 2. So I should have 1, 2, 3, 4, and then 1, 2, 3, 4. So the output of the max pooling layer should be 4 by 4. Let me run. So as you can see that our input image is 5 by 5, but because of the padding, it becomes 7 by 7. And then the convolutional layer make it a 5 by 5, and then the max pooling layer make it a 4 by 4. So again, it's keep reducing, but because we make it we do the padding equal to 1, we actually increase the image size the input image size. So here are the two important layers of calculation that that these two for the convolutional layer and the max pooling layer. So although when you do the model, you can just type in you can just do 2 lines and then you can finish building your model. But to understand what exactly these 2 lines are doing, there are actually more than two lines. So there are more calculation uh, that is behind by by just these two lines. So I hope you have a better understanding for the convolutional layer and the max pooling layer now. And that in the future, I will keep making more videos about the detailed concept of a convolutional neural network. So thank you very much, and let me know if you have any questions.